So welcome students. In this video, let us look at the analysis of the homogeneous equation ax square plus 2hxy plus by square is equal to 0. This is the most important topic of your pair of lines. So first, we know that this represents a pair of lines which pass through origin, right? Because the linear terms and constant terms are not there. So this represents the equation of a pair of lines, both of which are passing through origin. So pair of lines, both passing through origin. So let us say that this equation is made up of lines y is equal to m1x and y is equal to m2x. That means let us say that the slopes of the lines making this equation are one m1 and the other m2. Now, what is the relation between m1, m2 and the coefficients a, 2h, b? So that's what we are going to analyze. So to do that, there are two methods. The first is, so let us try to get the equation of the pair of lines y is equal to m1x and y is equal to m2x and compare it with the given equation. So if this represents the pair of lines which are y is equal to m1x and m2x, so y minus m1x times y minus m2x is equal to 0 has to represent the same equation. This implies y square minus m1xy minus m2xy, that is y minus m1 plus m2 times xy plus m1 m2 x square is equal to 0. So this is the equation of the pair of lines y equal to m1x and y equal to m2x. Again, I am saying that this also represents the pair of lines y equal to m1x and y equal to m2x. So these two lines have to be exactly same. That means the coefficients of the corresponding powers have to be proportional. So this implies what is the y square coefficient here? 1 divided by what is the y square coefficient here? B is equal to what is the xy coefficient here? Minus of m1 plus m2. What is the xy coefficient here? 2h is equal to what is the x square coefficient here? m1 m2 divided by a. So this has to be valid. This implies m1 plus m2 is equal to equate these two, m1 plus m2 is equal to minus 2h by b and m1 m2 is equal to a by b. So these are the most important equations in this chapter. So if you take a homogeneous equation, if this equation is made up of two lines whose slopes are m1 and m2, and the sum of the slopes is minus 2h by b, and the product of the slopes is a by b. So these equations look very similar to what you had in quadratic equations. So minus b by a, c by a. Here, just remember that, keep in mind that you have b in the denominator, not a. So minus 2h by b, it is minus of xy coefficient by y square coefficient, and the product of the roots is a by b. So these are the equations which you remember. So this same topic, same equations can also be derived by converting this equation into a quadratic in M. That is, instead of assuming y equal to m1x and m2x as the roots, let us say that y is equal to mx satisfies this equation. This y is equal to some mx satisfies this equation. So that means you get ax square plus in the place of y if you put mx, so you get 2HMX square, and in the place of y you get mx, so this becomes m square x square, so plus bm square x square is equal to 0, so this x square gets cancelled, so you get bm square plus 2hm plus a is equal to 0. So this is the quadratic which m satisfies. If the roots of this equation are m1 and m2, what is the sum of the roots? m1 plus m2 is equal to minus of m coefficient by m square coefficient, and m1 m2 is equal to constant by m square coefficient. So m1 plus m2 is minus 2h by b, m1 m2 is a by b. So let us see how we can apply these equations while solving problems.